In this video, we will be converting between natural logarithmic functions and exponential functions. Okay, so a logarithm with a base of e is Euler's number, 2.72, and it goes on forever. It's an irrational number. So if you have a log with a base e like this, okay, is a natural, what we call a natural logarithm. Okay, so if you see something like this, log base e of, let's say, x, you could say that can be written as, that can be written as ln of x. Okay, and you can convert back and forth between these two things too. Go both ways. Okay, so this is the e function. Okay, it's the Euler's number. E to the ninth equals x. They want us to rewrite this as a logarithm. Okay, so there's two different ways I'm going to show you to do this. First is the circle method. We start with this thing, the base, right here, and we swing around to the other side, and then we come back. Okay, that's the circle method, which means you change this into a logarithm with a base of e, because that's where we started, and that was the base here as well, right? Of x equals 9. Okay, and now we would want to convert that. We usually don't write it as log base e of x. We write it in the more simple way, ln x. So it would be ln of x equals 9. Okay, so another way to do that, I'll show you this other way that's a little simpler or a little quicker. Let's go back to the e to the ninth power equals x. Okay, you can do something called applying a natural logarithm on both sides. In other words, put an ln on both sides here. Put a natural logarithm there. Okay, when a natural logarithm and a e get together, they will cancel each other out. And whatever this exponent is what's left. So it'll be 9 is equal to ln of x, which is the same answer, just with the ln on a different side in the 9. Okay, so we're going to do it that way from here on out. So I'm going to apply an ln to both sides here. Okay, the ln and the e will cancel each other out. Okay, so the y stays, equals ln of 5, and that's your answer. Okay, if we apply ln to both sides here, okay, the ln and the e touch here and cancel. What's left is an x equals ln of 2. Okay, let's look at these down here. Okay, rewrite these as an exponential equation. Okay, so there's two different ways of doing this. The first way, which is the harder way, but I'll show it once to show you can use the circle method. Rewrite this logarithm instead of ln, write it as log base e. Log base e of 6 equals y. Okay, so I'm using this right here. Remember, they can be rewritten in both ways. So I'm just going from this way to this way. I do this so that I can use the circle method and change this to an exponential, which would mean e to the y power. So e to the y power equals 6. Okay, and that is your exponential. Okay, the other way of doing this, okay, is to, let's look at that ln of 6 equals y. I could apply e to both sides, just like I applied the ln. So I could put an e, and I can make this the exponent. We'll do the same thing on the other side. Put an e down as the base and make the y the exponent. Same thing happens. The e and the ln touch, they cancel. Whatever's left on the inside is your answer. So it's 6 equals e to the y, which is the same thing and a lot faster. Okay, so that's what I'm going to do on these next two. I'm just going to apply an e to both sides. The e and the ln cancel. You get x is equal to e to the 3. Okay, on this one, you apply an e to both sides. The e and the ln cancel each other out, leaving a 2 equals e to the y, and that's your answer. And that's it.